2 over 14. I can leave it as 1 over 7, but I just want to keep 2 over 14 there. The relative frequency of the second class is 0 over 14. The relative frequency of the third class is 2 over 14. The relative frequency of the fourth class is 6 over 14. And the relative frequency of the last class is 4 over 14. I think I need to grab this and move it up a little bit. I want to see if it's going to move up a little bit. Yeah, I'm going to grab it and move it up. Okay. Okay, so now I want to continue with my relative frequency. So the relative frequency of the last class is 4 out of 14. Okay, so now when I have a relative frequency column, now the graph can be called a relative frequency distribution. So this graph is now a relative frequency distribution. So that is a relative frequency distribution. Also, you could be told to find, by the way, relative frequency, I hope I have already explained that it is the frequency of a class divided by total. So it is the frequency of the class in relation to the total frequency. Frequency is the same as probability. So very soon in unit 2, we shall call relative frequency. Relative frequency is the same as probability. So in unit 2, we shall call relative frequency the same as probability. Also, let's put in another column of in that frequency distribution table. So let's go ahead and put another column in there. All right, so I'm going to bring this down a little bit. All right, so in this column, and I can expand this, and then bring this up. All right, so now I want to, excuse me. So I want to put in another column called cumulative relative frequency. So I want to put in another column there, and that column I can call cumulative relative frequency. In other words, I have to cumulate the frequency and then from that number to the top. So I will put an arrow. The cumulative relative frequency for the first class is 2 out of 14. The cumulative relative frequency for the second class is 0 plus 2. So for the second class, the cumulative relative frequency is still 2 out of 14 because the frequency of the class is 0. The cumulative relative frequency of the third class is 2 plus 2, 4 out of 14. The cumulative relative frequency of the fourth class is 4 plus 6, 10 out of 14. And the cumulative relative frequency of the last class, which is the fifth class, is 10 plus 4, 14, 14 out of 14. And by the way, the last cumulative relative frequency must always be 1. So very soon we shall tell you that the area under the normal curve is 1. That's where it's going to start. The total cumulative relative frequency for any data must be 1. Okay, so the total Probability must be 1. The total area under the number curve must be 1. And that's where it starts. Okay. So I extended the table from frequency distribution to relative frequency distribution to cumulative relative frequency distribution. You'll be seeing this in chapter 3, and I hope this helps you to do your homework when you get to chapter 3. All these are in the test, unit 1 test. All right, so the next thing I want to show you now is how to find what is called class midpoint. Whenever you group a class or a data, you must know how to find the class midpoint of that data. CMP, class midpoint. Class midpoint. So class midpoint. Every class must have a class midpoint. Every class must have a class midpoint. So I'm going to put CMP here, CMP. And how do I calculate the class midpoint? The class midpoint CMP is equal to the lower limit of the class. For example, if I'm talking about the first class, the lower limit of the first class is 0 plus the upper limit divided by 2. Therefore, the class midpoint of the first class is 4.5. 4.5. The class midpoint of the first class is 4.5. I'm going to put 4.5 here. Stop. All right. 4.5. The class midpoint of the second class is 10 plus 19 divided by 2. So that is going to be 14.5. The class midpoint of the third class is going to be 24.5, because when I add 20 plus 29 divided by 2, I will have 24.5. The class midpoint of the fourth class is 30 plus 39 divided by 2. That is 34.5. The class midpoint of the last class is going to be 40.5. Every class must have 44.5. Every class must have a class midpoint. The class midpoint is like the class representative. The class representative. Every class must have a class midpoint. The class midpoint is the class representative. All right. So let's talk about the other properties of a group data. If any data is grouped, the classes, so we have classes there. The first class is from 0 to 1. The lower limit of the first class is 0. The upper limit is 9. Looking at the second class, the lower limit is 10. The upper limit is 19. Looking at the third class, the lower limit is 20. Upper limit is 29. Okay. So remember, whenever you're looking for lower limit of a class, it is the smaller number of the class. And by the way, I want you to notice that the distance between consecutive lower limits, consecutive lower limits are equal here. 10 minus 0 is 10. See 10. 20 minus 0 is 10 again. 30 minus 0 is 10. 40 minus 0 is 10. Therefore, see this 10 is called the class weight. Class weight. Class weight. And the class weight is the difference between consecutive lower limits. Also, the difference between consecutive upper limits will be 10 also. It's also still going to be class weight or class size. It's also class weight or class size. Notice that the distance between consecutive class midpoints is also 10. Therefore, the distance between consecutive class midpoints and consecutive lower class limit and consecutive upper class limit will always be the class weight. And so if you are given a class, a table, a group data, and you're told to find the class weight, you will look at it, eyeball it, and it's easy to find the class weight because it's already given to you indirectly. Okay, so today we have talked about several things. We started with raw data. We sorted the data in ascending order, and then we made a stem and leaf plot. Then we did a one variable start, and we found out that we can find the standard deviation and variance from there. If I can find the standard deviation, then I can find the variance, because variance is the square of standard deviation. And then after we did the one variable start, we found a 5-number summary, and we drew a box plot and filled it with the 5-number summary. And so we know how to find the 5-number summary from one variable start. We know how to use it to decorate our box plot. We found our quartiles, and we found out that there's something called interquartile range. An interquartile range is Q3 third quartile minus first quartile. Okay, and we also saw that when the mean is greater than the median, we say that the data is skewed right. When the mean is less than the median, the data is skewed left. When mean is equal to the median, data is equal. Is bell-shaped. Mean equal to median, data is bell-shaped. Skewed right is the same as positively skewed. Skewed left is the same as negatively skewed. So we came to the same data. We decided to make a frequency distribution of the same data. So we grouped the data. I grouped the data to make it easier for me to manipulate. And when I have a group data, then I have what is called frequency. So now I have frequency. I have a group data, I have frequency. All right. So the next thing I'm going to do, the next thing we shall do is when we come, actually, we can do that now. When you are given a group data and you don't know the original data, the raw data, you can still find the mean, the 5-number summary, the median. You can still find the statistics. Whenever you're given a data that is already grouped, you can find the mean, the median, and whatever, all the statistics. All right. So let me see. So what I'm going to do is get a group data actually. Let's get a group data. So first of all, I am going to actually stop that again.